A logistics company is building a RAG application using Amazon Bedrock knowledge bases. Documents are stored in Amazon S3 and indexed using Amazon's open search service. Users report that search results often include outdated shipping policies. The company wants to filter results by document version and effective date without changing the foundation model. Which approach best addresses this requirement? A. Fine-tune the foundation model with labeled examples of current versus outdated policies so it learns to prefer current content. B. Use Amazon Comprehend to classify document freshness before ingestion and exclude outdated documents from the S3 bucket. C. Configure metadata fields, version, effective date in the knowledge base using metadata JSON files and apply metadata filters at query time. D. Increase the chunk overlap percentage so that more context about the document dates is included in each vector. Whenever you see, without changing the foundation model, filter results, current versus outdated documents, your brain should immediately jump to metadata filtering, not fine-tuning. Amazon Bedrock knowledge bases let you attach structured metadata, things like version numbers and effective dates. At query time, you can apply filters so that only documents that match a certain version, a date range, or any combination of metadata are even eligible to be retrieved. That means outdated policies never reach the model in the first place. Let's talk about why the other options are wrong. Option A sounds fancy, but fine-tuning is expensive, slow, and completely unnecessary here. You don't retrain a model just to filter documents. B removes flexibility. Sometimes you do need historical documents. The question explicitly says, solve it with metadata, not the model. The correct answer is C. Healthcare startup wants to build a patient portal chat box using Amazon Bedrock. The chat box must display responses to users as tokens are generated, rather than waiting for the complete response. Which API approach should the developer use? A. Configure Amazon SQS between the front end and back end to queue partial responses. B. Use Amazon Bedrock batch inference to process requests faster and reduce perceived latency. C. Use the converse stream or invoke model with response stream API to receive tokens as they are generated. D. Use the invoke model API with high max token value and parse the response incrementally on the client side. Is C, specifically for this use case. The two you need to recognize for the exam are converse stream and invoke model with response stream. These APIs send tokens back as they're generated, so the UI can render text immediately instead of waiting for the full response. That's exactly how modern chat experiences work, so C is the correct answer. The others wrong. A uses SQS, which is asynchronous and adds latency. Totally the opposite of streaming. B is batch inference, which is designed for offline jobs, not live chat. D sounds clever, but invoke model does not stream. You only get the response after generation is complete, no matter how high max token is. For real-time chat on Bedrock, remember, if users need to see tokens as they're generated, you must use streaming API. The correct answer is C. A financial services company requires all prompts and responses from their Bedrock-powered assistant to be logged for compliance, but PII must be masked before storage. Which solution best meets these requirements with minimal custom code? A. Store logs in Amazon DynamoDB with client-side encryption and manually redact PII quarterly. B. Enable Amazon Bedrock model invocation logging directly to Amazon S3 and use Amazon Macie to scan for PII after storage. The correct answer is B. This is a classic security and governance question. The requirements are very clear. Log everything, mask PII before storage, minimal custom code. Whenever you see those three together, you should think Bedrock Guardrails. Guardrails can detect and mask PII in both prompts and responses before anything is logged. When you combine guardrails with model invocation logging, the logs that go to CloudWatch or S3 are already sanitized. That's what regulators want to see. So the correct answer is B. Why are the others incorrect? A is an automatic compliance violation. PII exists unmasked for months. C technically works, but the question explicitly says minimal custom code. Guardrails are managed, Lambda is not. D detects PII after it's stored, which is too late for compliance. The exam strongly prefers built-in Bedrock security features over DIY pipelines. For PII protection on Bedrock, if it must be masked before logging, use guardrails, not custom code. The correct answer is B. The company's Bedrock-powered summarization API shows that 75% of the input tokens come from a static system prompt and few-shot examples that are identical across all requests. Which approach most effectively reduce token costs? A. Purchase provision throughput to get volume discounts on all token processing. B. Enable Amazon Bedrock prompt caching and place the static content in a cached prefix before the cache checkpoint. C. Use cross-region inference to distribute load and reduce per token. D. Migrate to Amazon SageMaker AI endpoints to avoid per token billing. The correct answer is B. This question is all about cost optimization. The key phrase is static system prompt and few-shot examples that are identical across all requests. That is exactly what prompt caching was built for. Bedrock prompt caching allows you to cache the static prefix of your prompt, things like system instructions and examples, so you don't pay full price for them on every request. You put the static content before the cache checkpoint, and only the dynamic user input is processed each time. That can reduce token costs by up to 90% for the cached portion. So B is clearly the correct answer. Why are the others wrong? A gives capacity guarantees, not token efficiency. C is wrong because it improves availability and not pricing. D adds massive operational overhead and doesn't magically eliminate token costs. The exam favors prompt caching questions. Expect more of these. When most of your prompt is static, cache is the prompt, not the model. The correct answer is B. The team has built a RAG assistant using Amazon Bedrock knowledge bases. They want to systematically measure whether responses are faithful to retrieve passages or detect hallucinations. Which solution requires the least custom development? A. Deploy Amazon CloudWatch synthetics canaries to replay test queries and manually review a sample of responses weekly. B. Calculate Rouge and Blue score between generated responses and source documents using Lambda functions. Use Amazon Bedrock model evaluations with RAG evaluation jobs that include reference context and measure faithful metrics. D. Export model responses to S3 and build a custom SageMaker processing job that uses an LLM to score faithfulness. C is the correct answer. The question is testing whether you understand how AWS wants you to evaluate GenAI systems. The phrase to focus on is least custom development. Amazon Bedrock model evaluations provide managed RAG evaluation, including faithfulness, which is the key metric for hallucination detection. You give it your prompts, retrieved context, and model responses. And Bedrock handles the evaluation using an LLM as judge approach. No Lambda glue code, no SageMaker jobs, no manual review. That's why C is the correct answer. Why are the others wrong? A, does not scale and isn't systematic. B, uses old school NLP metrics that can't detect hallucinations. D, works but requires a lot of custom infrastructure, the exact opposite of what the question asked for. For hallucination detection on the AWS exam, use Bedrock model evaluations. Don't build your own judges. The correct answer is C. A retail company needs to process 50 million product descriptions to generate embeddings for a vector search index. The workload runs weekly and can tolerate up to 24 hours of processing time. Which approach will maximize throughput while minimizing operational overhead? Option A, use Amazon Web Services Lambda functions triggered by S3 events to call the Bedrock Invoke Model API for each product description. Option B, deploy an EC2 autoscaling group that reads from SQS and calls Bedrock with exponential backoff for rate limiting. C, use Amazon SageMaker processing jobs with custom containers that call the Bedrock API in parallel. D, configure an Amazon Bedrock batch inference job that reads input from S3 and writes embeddings back to S3. Correct answer is D. This is a scale and workload pattern question. The important clues are 50 million items, weekly batch job, and can tolerate up to 24 hours. That immediately tells you this is not real time and not event-driven. Whenever you see large offline time-tolerant workloads on the AWS exam, your instinct should be batch inference. Amazon Bedrock Batch Inference is purpose-built for exactly this scenario. You give it input data in S3, Bedrock handles the parallelism, retries, and throughput optimization, and it writes the results back to S3. No infrastructure to manage, no scaling logic to write, no rate limiting headaches. That's why D is the correct answer. Why are the others wrong? A would create millions of Lambda invocations, which is expensive and fragile. B works, but requires a lot of operational overhead that you don't need. C adds unnecessary complexity when Bedrock already provides a managed batch option. The exam almost always rewards managed services when scale is high. For large offline GenAI workloads, if it's big, slow, and scheduled, use batch inference. The correct answer is D. A company is building a multi-agent system where one agent handles customer inquiries, another processes order, and a third manages returns. All agents need access to the same conversation text. Which architecture best supports this requirement? Option A, use Amazon SQS to pass messages between agents and store conversation history in Amazon Elasticache. B, create a single Amazon Bedrock agent with 3 action groups, one for each capability. C, deploy each agent as a separate Lambda function that reads and writes conversation state to Amazon DynamoDB. D, use AWS Agent Squad as a supervisor with Strands agents deployed on Amazon Bedrock Agent Core, sharing session context through Agent Core memory. The correct answer is D. This question is testing modern agent architecture, not basic AWS plumbing. The key requirement is all agents need access to the same conversation context. That's a shared memory problem. Amazon Bedrock Agent Core provides Agent Core memory, which is specifically designed to manage shared context across multiple agents. When you combine that with an agent squad, a supervisor pattern, you get specialized agents, shared session memory, managed orchestration, all without building your own state management system. That's why D is the correct answers. Why the other answers are incorrect? A and C require you to build your own orchestration and memory logic. B creates a single monolithic agent, which defeats the purpose of specialized agents. The exam is clearly signaling that AWS wants you to use Agent Core for multi-agent systems. For multi-agent systems on AWS, shared memory belongs in Agent Core. The correct answer is D. A regulated insurance company must demonstrate which specific documents contribute to each AI-generated response for audit purposes. Which combination of AWS services best supports data lineage and traceability? Select 2. Your answer options are A, enable AWS CloudTrail for Bedrock API calls and store logs in S3 for querying with Amazon Athena. B, use Amazon Macie to automatically discover and classify all documents that might influence AI responses. C, register data sources in AWS Glue Data Catalog with metadata tags and propagate document identifiers to vector store metadata. D, use Amazon Detective to analyze API call patterns and infer document attribution. E, configure AWS config rules to track changes to S3 bucket policies as the primary lineage mechanism. The correct answers are A and C. When we see audit, lineage, or traceability, think in layers. You need API level auditing and data level attribution. CloudTrail handles the API side, It tells you who called Bedrock and when they call it and with what permissions. Glue Data Catalog handles the data side. It lets you tag documents and propagate identifiers into your vector store so responses can be traced back to source documents. Together, these two give you end-to-end lineage. That's why the correct answers are A and C. Why the other answer options don't work. B classifies data, but doesn't show which documents were used. D is for security investigations, not data lineage. E tracks configuration changes, not document usage. The exam wants both who invoked and what data was used. For GenAI audit trails, CloudTrail shows who asked, metadata shows what answered. Correct answers are A and C. A company's customer service chat box handles both simple FAQ, frequently asked questions, 70% of the traffic, and complex technical troubleshooting, 30% of traffic. Using a single large foundation model for all requests is exceeding budget. Which approach will most effectively reduce costs while maintaining quality? Option A, enable cross-region inference to distribute load and reduce per token costs. B, reduce the context window size for all requests to minimize token consumption. C, fine-tune a smaller model on the company's FAQ data and use it for all requests. D, implement Amazon Bedrock Intelligent Prompt Routing or a Lambda-based classifier to route simple queries to a smaller foundation model and complex queries to the larger foundation model. D is the correct answer. This is a cost optimization by model selection question. The key detail is the traffic split. 70% simple, 30% complex. Using a large model for everything is overkill. Amazon Bedrock Intelligence Prompt Routing solves this problem. It automatically routes simpler prompts to cheaper, smaller models and only sends complex prompts to the larger model. You get lower costs, same quality, no user visible changes. That's why D is the correct answer. Why the others miss the mark? A, improves availability, not cost. B, hurts quality for complex requests. C, breaks complex troubleshooting entirely. For GenAI cost control, match the model to the problem. The correct answer is D. The team wants to compare 3 different Bedrock Foundation models on the same test data before deploying a new RAG application. They need metrics for correctness, helpfulness, and response latency. Which approach is most appropriate? Option A, deploy all 3 models behind separate API gateway endpoints and run an A/B test with live production traffic. B, use Amazon Bedrock model evaluations with compare feature to run evaluations against a shared prompt dataset in S3. Option C, build a step function workflow that calls each model and stores responses in DynamoDB for manual review. D, configure CloudWatch metrics for each model and compare latency percentiles after 1 week of production use. B is the correct answer. This question is about pre-production model comparison. Amazon Bedrock model evaluations let you use the same dataset, run the same prompts, compare quality and latency side by side, all offline, all controlled, all repeatable. That's exactly what B provides. Why are the other answer options incorrect? A and D require production traffic. That is too risky. C doesn't scale and relies on manual review. For model selection on the AWS exam, evaluate before production, not in production. The correct answer is B.